Welcome to Try a Maths Problem Today. In this video, we're going to be doing this relatively simple looking question you see on the screen. I say it's relatively simple because if you use a calculator, we'll be done in a few moments. Even if we go ahead and use the multiplication we learned when we were kids, you can multiply these two numbers, then multiply these two, then take away those two large numbers away from each other, you'd get the answer. What I'm going to do here is I'm going to do this a couple of more interesting ways. Of course, if you haven't already, I do recommend you pause the video and try these questions yourself. You'll probably come up with a more interesting way of doing it than I did. The first thing I came up with is I noticed some numbers repeating in this question. I see 99 a couple of times. I see it here quite obviously, but I also see 99 over here multiplied by maybe 100 plus 1. I'm going to make use of that fact. Now, the method I'm about to do, I'll actually do it twice. So if you don't follow the first time, I'll do it a second time. Instead of taking 99 out, I'm going to notice that 101 is there and it's identical. The same way I'm going to do this each time. So first of all, let's find 99 in this first term. I'm going to rewrite this as 99 times 100. That would get me 9,900. If I add 1 onto that, I get this number here. Now we'll keep that in its original multiplication bracket. That's going to multiply by 101. Then take away 99. Nothing will change on this side. Now that I've isolated 99, let's go ahead and isolate it from everything. So we have a 99, and what multiplies by that 99? This one will be quite easy, it's just this one number. Over here, what multiplies this 99? This 100 does, and this 101 does. So we get, let's multiply these together. 100 times 101 is 101, or 10,100. What else multiplies by a 99 in this term? This number here does, and there's a minus here, so it's minus 10,101. So that's taken 99 out of that. What's left? Once we've taken out this term, this multiplied by this, and we've taken out this whole term, the only thing left is the 1 times the 101. So we get plus 101. This is quite easy to do in your head. This number here becomes a minus 1 times 99 plus 101. Well, that just becomes 101 minus 99 equals 2, which is the answer to this entire question. Now, don't worry if you didn't follow that, because I'm just going to do it again, but this time I'm going to notice 101 is special. Once again, I'll do the same trick over here. I'll get the 101 out of this big mess. It's actually 101 times 100 with a 1 added on to the whole thing. And on this side hasn't changed. It's 9,901 times 101. If we take 101 out of everything here, where does 101 appear? 101 multiplies by this number, 9,901. 101 also multiplies by this 99 and this 100. So we multiply them together. 99 times 100 and this minus out front gets us 9,900. And what's left? What term did we not deal with at all? This one here. This one will multiply by this minus 99. So we'd be left with a minus 99 at the end. Once again, we can do this in our head. It just becomes 1 multiplied by 101 minus 99. That's 101. Take away 99 will once again equal 2. Now, for a more interesting way to do it, and probably a little harder and a little more silly, I'm going to look at the fact that I see 100 a lot. Forget 99 because it's close to 100. 101, close to 100. A lot of things were multiplied by 100. I see hundreds everywhere. So let's go ahead and replace all these times we see 100 with the letter X and see what happens. So for example, what I mean is that 99 we see in here. Let's write that as, let's give ourselves plenty of room, as X minus 1. That's this 99. And what's that multiplied by? It was multiplied by 100. So we multiply that by another X. And then we add 1 onto it. That's just to get this one term. This first term here could be wrote like this if X was equal to 100. 101, well that's a bit easier. That's just X plus 1. could be wrote like that. Over this side, we would have 99. Well, that would become x minus 1. What we have here, 101. We did a few moments ago. 101 times 100 plus a 1 on. So that 101 would be x plus 1. It would be multiplied by another 100, which is x. And then there would be a 1 added on. That's all one term that's multiplied by this 99 here. A bit of a mess, but we can multiply all these out. Let's start inside here. This x multiplied by here, we'll get an x squared. X by minus 1, we'll get minus x. Then plus a 1 on here. And that's multiplied by x plus 1. We'll go ahead and multiply that out next line. Over here, we'll get something similar. The x minus 1 multiplied by this multiplied out. X times x is an x squared. X times 1 is x plus another 1. We get these terms. Again, we're just going to multiply these out. X multiplies in here, we get an x cubed minus an x squared plus an x. The 1 multiplies in, we get an x squared minus an x plus a 1. And over this side, let's put a big bracket around everything so we don't lose this minus here. A big bracket around everything should all fit in here. X times all of this, we get x cubed, x times x squared. X times x is x squared plus another x minus 1 times everything. Minus x squared minus x and minus 1. We clean all this up. What do we have? On this side, this x squared and this x squared, that's plus x squared minus x squared, they disappear. X and a minus x, they disappear. Same happens over here. X squared minus x squared. X and a minus x. All we're left with, let's write it up here. On the left side is x cubed plus 1. That's all that's left over there. Take away what's over here. X cubed minus 1. That's another plus 1. The x cubes cancel and we're left with a 2. Just like we found in the other way. I'm fairly sure there's even more ways to do this question that, remember, can be done on a calculator. So please let me know in the comments if you know a different way to do it. Thanks for watching and have a great day.